all it needs is to it has to be in a format, maybe Excel or rest of them. So for example, I'm going to bring in this data here, so and I want to bring it in comma delimited value. So like this one now is about 28, and you can see the length of the data here. So I'm going to like copy, like I'm copying here. So in this case, to be copy, I can return down here in the data section, like and then we can paste it here. So I'm going to paste the data here, and you see in here is asking me for the data. So I'm going to make it sample points, like as it close up, then I'll click OK, and that's going to open for me like this. So you can see the serial number, the longitude, the latitude, the y15, and depending on what it is. So with this, if you look here, you see that inside here I'm not in the right directory because I'm using Pandas, but it is showing me here. So what I need to do is to change the directory. So I'll go to terminal and the cd double dot, which is change directory, step backward. Now when I step backward, you see I return back to the parent directory. So if I type directory, I should be able to see all the directory that is here. So I want to change to Panda, that is Pandas here. So what I need to do is to see change directory, and I type Pandas. So for me, I'll type P and press tab. And once I do that, it now take me to all the P here. So since I'm in Pandas, I'll click enter. If I click on directory here, and you can see that all the data we have in here are there. First, you can see the data folder here is a directory, then this one also, then this one is a file as well, so you can see the size and the length. Now because I want to launch this, so I can actually reach and type Jupyter Lab. Now this will actually open the Jupyter for me Lab on my browser. So it's going to open up the Jupyter Lab in my browser. Now remember, I just added this data. We were using Nigeria Health Facility, so I added this one 3D coordinate and rest of them, so which I just copied and pasted new. Now on this I've actually loaded in my local here, and then localhost here, and you can see here it is coming up here. Now this was the file we used last time. Now remember what I talked about. Now look at the data which we have, the same thing we have here, which if you go back to PyCharm here, you can see them here. Now if you go down back to the place we are coming from, you remember the places how we imported Pandas and rest of them, how we imported the data here. Like if you look here, this is when we access the table, but if you look at this, you remember that we access the data using this way. So for my case, I'm going to return down here to start up with the new data I want to work on, maybe any data that I want. So I can click add here. So in this case, I can just name it whatever I want. So maybe let me start with sample. So I'm just going to type sample is equal to, then if I want, I would still do PD and then dot like we know, or I can just paste this one I copied here and then change the directory with samples because I want to name it as samples. Now if you look here, you see that this is the directory here. For this one, I want to use the sample point here, so I will right click on it and say copy path here, and then I will bring it in here and replace the path here by pressing Ctrl V. So you see it is here. So if I run this particular one right now, you see now that it is reading here and it is telling me that PD is not defined. Why? Because I didn't run the first line here where I have import Pandas as PD. So in that case, to make it, because it have stopped, so for me to make it work, so I have to now go here and say import Pandas as PD. Now if I run this, and this is not going to tell me false, so you can see here this is successful and there is no problem. Now if I want to see the data, remember what we talked about, so I can do sample.head, and then I should be able to see the head of the data. So you see here I have 0, which is serial number, longitude, latitude, y15, 21, and 25. So this is the data as it is. So which I can also say sample.info, because I want to know the type of data it is. So I can say sample.info, and then when I run this, I should be able to see that, oh, the total data is 600 from 0 to 559 in the index, and then it is about 6 column, and in that 6 column, serial number is in integer, longitude is float, latitude is also float. Why this is so, the rest of them is float except the integer. And if you look here, you see that this have point, 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 and this have point. Now with this, I should be able to know what is the details about the data. Now remember what we talked about last time on how do we access those data, and today we are going to be talking about how do we plot, how do we visualize the data we have in Excel. So there are several ways in which you can visualize this data, either Excel or it is in CSV or different other type like a test format. How do you visualize them? So in visualizing, I can just say, for example, I can just say sample dot, and I can say plot. Then when I put this and run this particular column, what is going to happen is going to plot for me whatever it sees here by automatically. So you see here serial number goes here into 600, and then the longitude goes whatever it was. So this is just like a way you just want to see it getting plotted. But remember that in head you have visualized what is the head of each of the data. So it means that you can plot by just calling the sample.plot gives you the plot you want to plot. But you know there are different other types of plot format that we can look at, which you can be line, point, or polygon. So it can be line, sorry, it can be by point, by scatter, by bar plot, by bar H, or different types of plot. But in this case, I just wanted to see randomly what I have looks like in here. So in this case, I can now decide to plot the data I want. So by plotting, it comes by default. But what if I want to look for a particular data I'm interested in? So that means, assuming I want to plot the serial number, for example, I can just say in here that I put dot. So I will now call it at a list like sample. Then I can now call this as a list. And remember, I've already visualized what my data looks like. So I have serial number here, which I can just come here and copy, and then I'll paste it here. And then if I close this up and I say dot plot, so what it means is that I only wanted it to plot for me the serial number. So this, you can see now the serial number goes in like this. So I have another column which is longitude. If I call that particular longitude, which I just need to remove this and then press the longitude, and if I run it, that's going to plot the longitude in this particular part for me, because if you look at the ranges of my longitude, you can see that it goes in this particular format. So this is the pattern for plotting the longitude against the serial number, because it's 600 of them. Then if I want to plot the latitude, I also have to do the same thing. Latitude, by just calling it, and this is the latitude plot, which is in negative against the 600 of them. So what am I trying to say? You can plot the numbers you want. If I want to plot this one, I can also come here and represent it like this, as you can see here, and I will run it here. Now when I run it, you can see this is the changes over the 600 point now here. So you see now that this comes in here. Now if you now say it is because it is 1 and 2, so you can choose to plot it in y and x or wherever you want to plot it. So in that way, what I just did now is that I just say plot this. So it's telling me that key error longitude and latitude here, because I plotted them in this same format. So that's not just going to work, but there's a key error here, self-indexing key. So now this is an error, so which doesn't supposed to flow in this way in plotting them. But what I'm trying to say is that if you look at this, you see that you can visually just visualize what you want the way it is. So this is the changes of them over this period of time based on the data I have. Now if I want to plot this in as a scatter, So I can bring it in different way to plot them in scatter. What do I mean by plotting them as scatter? So in this particular one, I can just say in that way. You just need to change whatever you are plotting. For example, let me explain what I'm saying well. If I want to plot this in pattern of scatter now, so I will now have to come to the data here, which I say sample, and I say plot dot, and I mention scatter, that I want it to be in the scatter format. Now in scatter, what do I want to plot? Let me assume that in the x-axis I want it to be longitude. So I'm going to longitude, and then in y I want it to be the latitude. So I'm going with the latitude in y, latitude in y, and then if I run this, now this is the plot. This is exactly how the points scattered over the place. So what I mean now is that you can see here that I have plotted this. This is a point scattered of longitude and latitude over this place. And now this is actually the true representation of the data that I want and how I want it. I don't know if you get what I'm trying to say. Assuming you want to visualize the x and y of a coordinate you have using Python, this is exactly what I did here. So if you look here, you see that this is my longitude and latitude, and this is exactly what it looks. So x is longitude, y is latitude. So this is a way I can plot them and show the representation where. So in this way, remember we have other rights to say color. So we can say make it in red, or we just say red here, and then we run it again. What happens to it? It brings us to, okay, there is an error, which is the got unexpected keyword colors. So let's go in here to see what was the problem. What is the problem here? So it is, I put color. So now this is a point, this is a longitude and latitude. As you can see, if you go here, you see it is a longitude and latitude of a data. So I want to plot it in the part, because remember, while we are gathering all these things, like I said, that we're going to be using this thing in different aspects, seaborn, map, geopandas. We just need to know how we are going to bring in data, because I am not going to repeat this one backward. By the time we start importing data, like I want to start creating a web map, so and you have the data you need to use to plot, I won't be repeating this, because I have shown us how to import the data from here. I've shown us where we put the data, how I imported it, and how I was able to read this. Now I am showing you how you can plot the geographical location of them, so you can see longitude and latitude. If the other one is latitude, I just need to change the variables here, and then let it know that, oh, you are latitude, you are longitude, and then you see automatically I change it up here, because I put x, latitude, y, longitude. But ideally this is how it's supposed to be. So I am going to put x here, and then I'm going to put y the right way it is, and then I put color to be red. And if I want to change it to blue, remember, you just need to come to color and say put it in blue. So you can see here, if you want it in green, you can also change it here to put it in green, and then you see this is it here. So practically, this is exactly the way you can actually get it done, and you see now it's showing me longitude and latitude. Now remember, we can also pass alpha to it, and then I can say alpha is 0.3, and if I run it, so you can see the visibility here. And if I say let the alpha, let it be 0.9, and if I run it, and you can see it is full here. If you remove it, it will be by default, which is 1, which it shows you the full color. Now if I change it into 0.1, you see it being faint here. So you remember the keyword we use when we're talking about matplotlib. So this can also be used anywhere you want and how you want it. So if I make it 0.5, this is how it is. What if I say let me also make it better by saying, let's say style, and then I type style. I think we are okay with this, and then I decided to say that the style I want is, let's say here, and then let's go in like this, and then let us run it again, and you see this is the style I want it. And if I put style and I say X, and then you see different styles, so you want it. So remember, we talked about style last time. So but what I just want you to know is that how do you put up this. So whichever way you put it up, and then this is the best way you can visualize the data you want at any point in time. So for me, I just put it 1, and if I remove the alpha here and just run it like that, and that's going to give me the color in this particular pattern. And if I want the color to be black, remember I can use key and then I'll put it up here so it become black. But what I'm trying to say is that anytime you bring in a coordinate and you want to visualize the x and y locations of it, so this is a practical way or perfect way you can visualize it. Now nevertheless, we can also not just only plot scatter, we can plot it by line. For example, if you have this by line, so this is what you have by line here. So what is joining, you have the longitude and latitude, and what is plotting automatically here is the x label as you have here, which label is by line. So there are other ways you can also plot it again. I don't want to put something about, you can also plot by histogram, and let's check what the histogram can give us. So this is what it shows you by histogram. Remember the keyword histogram. And then what if you say you want to plot by, let me not use bar because that might consume the memory, but let's say that I want to plot box. Then this is what box looks like, the plot box. So you remember I just need to put box here, and then you can also plot by KDE, which is scanner density. So this is saying that the skipped a no module name KDE. So you have to be looking for, you have to remove the Y array. So these are different method, but for me, let me quickly check what is wrong here. So I can say I think we name it as, what do we name that particular data? So sample. So let me still use sample, which is equal to, so let me still use the sample we're using. So sample dot plot here. So we have, it comes in like this, and then sample dot plot dot line, and then we have it plotted in line like this, sample dot plot dot kde, and then this is not going to work. Okay, so because we needed to import no module access file that is attached to it. So so this is it for this one, so which we are going to use it. So we can also plot it by area depending on what you have. So this is by area. So there are different other ways you can plot it. If it is something that need to plot by pie chart, I'm just giving us a keyword of what you need to plot. So you need to put pi, and then if it goes in with the pi does not allow negative values because it is pi. And why? Because the latitude is giving us in y part, so that is why it is not allowing us show or display the y part aspect of it. But if you go in here and then say here, let me take it down a bit back to x, so I'm going to remove what I do. So I just say sample, and then the sample which we use is the name of our data. So let me make a mistake, the name of our data. Then you now call the layer you want to plot. So in that way, so I'm going to use the longitude here, which I'm going to put up in longitude, and then I am going to say close it up, and then I say dot plot it. So if I run this one now, so I should be able to have this now. So what I'm saying is that you see the way I have this, because I plotted longitude here, and that is why it is showing me the longitude here in that part. So if I say plot this in and say y15, like the way I have already here as head, so I can just come and copy any of them and go down there and then plot, paste it here, and then I run it here. So I should be able to have this looks like this. So I can put up the color that I want it and how I want it. Now remember that what I'm trying to explain here, that here I want to plot this differently. So I'm going to paste that I want this one to come here and I want this one to come here. So I'm going to modify this thing to be 15 and then make this one to be 17 based on the data I have here, what I have here as the title. So if I run this particular one, what happens here? So you see here that I have, because I have scattered, this shows me in scattered format with those points having y this way and this way. Now what if I now say show it to me as line, what happens now, you can see the line moving in this particular pattern with the difference of here, the y15 and y21 on it. And if I say put it to me on histogram, so if you put it in hist, then you should be able to have this in this pattern. Now what am I trying to say? There are different keywords you can use, but you remember that this is pi. Pi is saying that it doesn't require negative value, so it can't work with negative value, so we won't be able to use pi in negative value. But we can use them like hexabin. I think hexabin should be hexbin. Yeah, if I can remember very well. Let me check. Yeah, so this is hexabin. So this is a different ways you can plot this. You can see this differentiation here. Remember what I showed also. You see, this shows you where the color is. This is 0, where the color is about where it moves into 2. And remember what I said before. If you want to look at what you need to do, go to conceptual show here and read the documentation. It should be able to give you the view of what you can plot here. So if you look at plot here context, so you can see here the common kind of plot you can do here is line, bar h, density. So here I can copy density here and then come in here to paste it here, and then let me run it. And what is he saying here? He says there's no, so some of them require external distinct to be able to work. But what I'm saying is that if you look at, see that this is the documentation, and that is how I know that the data I worked here, which is what I selected plot here, can be displayed in density format. So you can see the kind is line. You can see kind line. That is the ways it can also be visualized. So what I'm saying is that you can come here to look at the documentation. You see line, bar, KD, density, area, histogram, bar plot here. There are some other series you can plot like pie chart. You can also do data frame kinds of scatter and hexabin. You can also do this also in density and KDE. So these are different ways you can just come in here and look. So that's how I know that, oh, I can actually use bar or I can use density or area. So that is the reason why I come here and change in that, oh, if I use area here, what should happen? I should be able to have something to be plotted here. So this is a way you can visualize a data that same way. Then, like I said, you can use different types of data in to plot that. So all you need is when you access it and know what do you want to plot, and you should be able to plot what gives you the best visualization. So if it is line, I just need to change line here and I have this. If it is point, which have to be scattered, so you don't have to go here and type point because you want to plot point. There is nothing like point here, but if you want to use that, you use something like scatter. So in scatter, you should have something that looks like this. So which here gives you color. If you remove the color, like I can remove it and run it, it gives you the color by default to what it is. Here, it label it here and also label it here for you. So this is a way you can make a kind of plotting using this particular pattern. So define what you have in the box. If it is y and x, you put it up here. And if you want to put color, remember to go with alpha, which is easy from 0 and 1. So if you want to make it transparent, so if I put 5 here, you see it reducing to this pattern. So it means that if you have a data in Excel, so you can plot what you want to plot at any point in time. Now this is the scatter plotting over here, and then you can also plot a subplot. And then when it comes to subplot, what do you need to do? Let's say I want to plot in this particular axis, and I can also say the same thing, the data we are using, or now we are using samples, I think sample, and then we can say plot, we say dot area if it is area that we want to plot. So what do we need to do in that particular pattern? So once we go there, we can now define the figure size, so which is a keyword. And when we say the figure size, we can say, let's say 12, and then let's say 12 making it into 4. And then what else do we need to do? So we can say in subplot that let it be true because we want to look for subplot. So in subplot, so we want it true, and then when you close up the bracket and then you run the data, This is trying to tell us that the 2D set got unexpected argument subplot. So let me go back and see what was the problem. Is this supposed to be subplot or subplot? So let's run it up here, and then I'm having an error that comes in like this. But you can see that it is trying to tell me that for me to use a stack true, each of the column must be greater than positive or all negative. A column this contain positive and negative value. So you can see here I am able to have this kind of data set. So I made a subplot of 1 2 3 4 5 6. So it is the why is it 6? Because I have the total of my data as 1 2 3 4 5 6. So what happens here, because I said subplot the everything here in area, so what happened, it gives me here 0 to 500. Remember, this is a serial number and it moves in that order. In this next one is longitude and latitude, which ranges from 0 to 30, and then it goes from negative here in this pattern, then it goes, so it brings everything in here for me, but it's giving me a warning because in that order. So if I say scatter, for example, and then I run it, what then happens? So it is trying to tell me that the scatter is missing two required position of x and y. Sorry, so in that way I needed to define the x and y to be able to plot what is supposed to be the way it's supposed to be. So it have to be in a position of x and y like we did last time. So now this is just a way you can plot this. Now if you look at, I used line on this, and you see that the serial number ranges from 0 straight to here, and then this ranges from negative because this is the order it changed, which is longitude, this is the latitude, this is y 15, y 19, and y 23. So you can see the order format it goes. So you can visually use different types of plotting to go whatever you want to go, however you want to go. But what I'm trying to say is, look at the frequency here. This is the changes it plotting over the based on the data we have. So all you need is to understand uh, this type of data you are using, and you should be able to use it to visualize what you want to plot. So it is easy and it is very simple to access. So in that way, so you should just know which one are you plotting, the x-axis or y-axis, because that's for this one. Remember what we did here. So it is now asking me what is the position of x and y axis, which ideally I supposed to have here, and then define it whichever way I want to define it. So I should be able to have them here. So this is what happens here. So I have put to x, y, and z here, and then I said plot it in hexagon, which have to be in subplots. But see, it didn't bring it in subplot because the figure here is not like that. So these are different ways you can access or you can make a plotting using this kind of method. So you can add whatever you want to add, you can change it whichever way you want to change it. But what is important thing is that you should know how to access any data you want to access at any point in time, and then should be able to use it to plot all you need to plot. So this is just a simple example of what I'm trying to say here. So you put it up the way you want, and that displays in for you, and it is fast, easy, depending on the type of visualization you want to visualize. But one key thing I want you to take home, or I want you to understand, is that if I give you an x, y, and z, then I want you to plot it. So you should just know that since we have a kind of sample here, so you should know how do you call the data to be able to plot the x and y. So for my case, let me make a repeat again. So I'm going to do a repeat. So I want to just say scatter, and then I now go in and say in the x-axis that I want it to be the longitude. Already, how do I know the longitude? Because I have read the data and see that this is the longitude. And then what do I want to be in y-axis, and I want it to be in the latitude. So how do I know that is latitude? So because I have already reading the data and see that this particular part is housing latitude. So latitude. So when this is done, and I can close the bracket and I can run that, so automatically I can get the map or whatever I want in this particular format. Now I made a mistake. So if you see here y latitude x longitude, so if you do that, you should be able to have a pure data representation of what you have to have. Now remember, how do you bring in the data? So I can now say, remember the data imported, how I copied from the first place. Now look at this another coordinate here, so which I'm going to PyCharm to click on the coordinate. And in coordinate here, you see I have longitude, latitude, and then I have bulk, green, saturated, I have eastern, I have northern, I have x, y, z. So what do I need to do to bring it in here? So I return back to the same place I am, and I can say, let me call this one chord. And then what do I need to do? Remember, I have to do pd dot, you do your read underscore, because it is CSV, so I'm going to say CSV. And then what else do I need to do again? I open up the bracket. Now I go to the coordinate here and I copy the path here. And then what do I need to do? I'll paste it here and then close the brackets. Now if you run this particular code, you see this is okay because the data is existing. Now what do I need to do again? I have to do code.head to see the type of data that we have here. So if I run it, I should be able to have that I have longitude, latitude, saturated, and rest of them. So if I want to plot it in longitude and latitude, what do I need to do? I can now say, because we're using chord, so I can now say chord, which is a coordinate dot, and then I can say, let's start with the plot first, and you see that this is going to plot this in general format for me. So you can see here, by representing all of them to know, tell you which one we're talking about. But now we want to now go ahead to plot a particular data among all of them, like this one. If I want to plot saturated, I can go ahead to pinpoint only saturated. How? By just going to code here, and then I open the list, and then here in here I've seen that it is green, so I can copy it. Then I will now paste the green here, and then when I paste it, I will now close it up. I say dot plot it. So if I run this now, I should be able to have the green. So this is the the distribution of the plane green from 0 to whatever it is. So you can see this coming in this format. So if that's not what I need, so that I needed to plot the x and y position, I ask you plot the xy position for me. So what I need to do is I need to go in here, see say the chord, because that's what I named the data, and then I can say dot plot the scatter for me. I have to say dot again, and I say scatter, and then I come up, what do I want in y-axis? From my data which I have read here, I've seen that it is called long, so I'm just going to type long here. And then what do I want in y-axis? So I'm going here to type in the y-axis, I'm going here to type lat, and then if I close the bracket and run this, what am I supposed to have? So this is the spatial distribution of the longitude and latitude of this over this place. So if I want to change the axis, I can change y here, and then I can change x, put up x here, and if I run the same thing, and we are going to have it in this pattern. So what I'm trying to say is that I can plot the spatial description of longitude and latitude now. Because it's longitude and latitude, I can also represent it with eastern and northern. So in the x, as we know, so let me revert back to what it was. So by pressing Ctrl Z, and then if it is eastern, so I can paste eastern, and then what do I have here? I have nothing, so I can copy the nothing, and then here I can paste it. Then I'll close up this, then I can run this. So you can see the same thing we have in eastern and nothing. The difference is that we have projection. So when we're using Pandas, we should be understanding when we say CSR, which is coordinate reference system. So that's when we need to know the difference authority ID. So I will not be jumping into it today. So but if you go to CSR authority ID, so I think it should be getting to what I want, but that's not what I want. So I'm going to say coordinate system authority ID. So we are going to be using this very well as we going on, because we are going to be talking about this part, and we are going to be using majority of those authority. They assuming you want to have a data and you want to move it from a particular coordinate system. So if you look at authority ID here, UTM zone 33 north, So if you look close, you will definitely see this is 1980 Clark, and then if you look at it, you should be able to see the authority ID. So this is authority ID for this one. So if you remember that WGS 1984 have authority ID of 4326, so we are going to be using that because when we want to read project, when we're using Jupyter notebook or any data we have, we don't have to be going ahead to be saying this is the CRS code, so we don't have to be going ahead to be looking for it on how to reproject. What we just need is what is the authority ID. So we pick up the authority ID, the coordinate reference system identifier, and automatically we put it in there, and it should be able to move it from one particular distance to another. So what I'm trying to say is that if you look here, you see, even though we have the north and the east here, both of them are saying the same thing. So you can use anything and anyhow you want it, in as much as that's what you want to plot. So here I have xkm, and then here I have ykm. So if I want to plot it, you can see here the same thing here. So you just by different way, different this thing that they are, so which you can always transport. So this is a way you can bring in data. Also, if you have all these ones, like if you look at this, returning back to the 3D maps here, and if you look at this, you see that this is also in longitude and latitude, and then this is the crustal height and thickness. So this can also be plotted as well, whichever way you want it. The same thing I said, you still have to return back here and define the data. So I'm just going to make this one maps, and then in maps, so we are just going to see pd dot read underscore csv, because that's a code which is supposed, the keyword is supposed to understand. So you return back to where the map is, and then go here and say copy path, and you should be able to paste it and close it. And then for me, I'm just going to say maps dot head. So and I can run it, and I can get the head, the read through this. So I have long lat. So if I want to plot, so I can just say maps, because I'm using maps here, maps dot plot, and then I can run it, and this is going to give me all the data as related to it. So it is still running, so you can see plt.ddis. So if I'm interested in plotting any of them, so I still have to say maps dot, then I now name the what I want to plot. So I have to say plot and then dot scatter, for example, and then I can now go in, and what do I want in X? I can say that I want in X based on what I read here from the head. Then I want the X to be the long, and then I want the Y to be the lat, and then I can close it also. Who can tell me what is wrong with this? Are we still together? Are we together?
Yes, we are.
Yeah, so what is wrong? What is wrong with what I wrote now? Why am I having an error? If you are still together with me. Nolo, are you here? Nolo, are you with me? Who is talking, please?
Yeah, it was telling.
Okay, Sterling, so what is the problem with this particular code now? Why am I having an error? If you understand what I'm trying to say.
I from what here it says that the longitude is not defined.
So how do I make, because I wanted to see the spatial distribution of this particular, I think, maps here. So what's the error here?
I'm not sure. I'm not sure about it.
So can you call, you have one lifeline, so can you pass it over the next person that can help us? because it says long and lat is
I
not
think
defined.
Pablo is on the call.
So Pablo, can you
Pablo is on the
help us?
call. So
The error is an error because I think we don't do the last post first. Should everybody
Pablo is breaking. I don't know whether is it only me or all of us, because what you're saying is actually breaking.
I think it's breaking. Is it not the what do you call it? The the apostrophe that's not there.
Okay, so that's actually the problem.
Yes,
And
yes, the apostrophe.
this ought to go in here, and then when you run that, you should be able to call the right thing you're supposed to call here, so you can see the way the 3D map is looking. Why? Because the coordinates we have here are all patched up. So you can see here 280, 280, 280, 2690. So you can see almost here it is stiff and it's the same thing, and it is long. So this is about 300 and 303 million, is it 3 million or 300 something thousand points. So it is very very long one, as you can see here. So it is a very long one. So when it patched up, so it patch up in that particular format. So nevertheless, you can see we have thickness and density, so you can always plot the one you want to plot in that format. So if I change this one, copy, and go in here and say put the density here, and then return here as well, and then go ahead to copy this and say put the latitude in this format. Then I will run the same code again, then to see what we have here, so you can see the patches we have here, so the way it is. So remember, if I want to switch without this, I can just switch this thing to y, and I can also switch this one to x. And then if I run this same thing, so you see it's changing the orientation. So what am I saying? This is a way you can make your different kind of plotting in this particular format. So you just need to note this, and then just know how do you bring this into this, because this, if it is a kind of longitudinal profile, so you can plot. And remember, like I said, we are going into deeper aspect of this, because if you look at what we're supposed to be doing, you see that we have a lot of things to do. So we are going to use Seaborn, we are going to use Pandas, we are going to use different things using Python. So we are going to be working on Matplotlib, which we talks about. So we are going to be working with raster. We are going to be working with writing the spatial data using GeoPanda. So if we don't understand these particular things, or how do you bring this data, how do you transform your data into points in coordinates, how are you able to plot all these things and able to make them visual, because we are going to be having an interactive plotting where you can zoom and then click on each of the points. You know that this is what this point symbolize or what it means. But what I just need you to understand is, based on this, I think we don't have issue on how do we bring in data into how do we bring in data. Like I said, for some of us who did not join us on time, any data you have, let me just go. I don't know which random point I just need to pick, but any data you have that is in X and Y or wherever it is, all you just need to look for the data, and then when you get the data, look for which format is it. So you can see here, this is Excel. If it is Excel, read it in Excel format. So if you look here, you can see different types of data. So as you see here, this is X and Y, as you see it here. So it is in Excel. Remember, I can just copy this extracted. So I can copy it because remember we are here. So I will now return back to this particular location of this, and I can decide to paste it here. So if I paste it up here, it comes in here. So I name it as extracted. So it automatically knows that the data we're talking about now is extracted. So if I add it up, this is going to open up here for me. So because I just want to use it up here, so it is Excel. Now it is not going to open for me because it is Excel, so I have to install the Excel file that will view it. But if you look down here, you see that the Excel file have opened for me here because I have Excel reader here. So you see it is have opened down here for me. So if you return back to your Jupyter Lab here, which we launch, so if you probably refresh this, you should be able to see the Excel which we are working with. So if you return to the data we pasted, so you can see the Excel file here. Now in this case, I can decide to copy the path as well, and then I will return back down here, and then you can say call it, let's use it dx, and then remember that you just need to say, now you're saying panda dot, you're going to say which, how do I read Excel, because we have talked about it last time. Who, Sterling, do you remember how we say we are going to be reading Excel?
Yes.
So
Um.
what am I
Yes.
supposed to do? Because I
Panda
want,
dot reach. Yeah. You should write dot reach.
so dot
Then
read,
you call the format underscore
uh-huh,
underscore.
uh-huh,
I think should be read underscore. Then you call the format. Excel should be XL XSL.
like
Mm,
this.
yes.
Okay,
Yes.
so what you
Yes.
mean is that I should put
Then
it
you
up like this, and then I'm going to copy the part here. Is that what you mean?
paste it.
What
Yes.
if I say you're wrong?
XLS. Mm, that's not oh,
Because you remember
okay.
that we treated a keyword both when we're using GeoPandas, you remember? So there is a way we say we can read Excel file. Okay?
Oh,
Do you
okay.
remember?
Yeah, there was a way you said it was confusing, Sha.
Do you remember this type of thing that I type here, where I said Excel here?
No, I don't remember this one. Excel.
Mm-hmm.
Hmm. Yeah,
Pablo?
it's giving us error.
Pablo?
Yeah,
Yeah, so do you know what is wrong with this right now? Okay,
yes,
so
obviously
yeah,
is CS.
to save us our time, when you are reading Excel, so you are supposed to also have, let me go in here, and then we are in GeoPandas. So either you install using bash, but we can also install, either you change it to CSV, but I'm just trying to tell you that you can also install using different like different other ways, that is not only Excel. So you can just put PyExcel, and then if you do pip install open Excel, so that is going to collect, download the data that related to Excel. So I'm saying that, what if all the data you need to install is not in, that is not in is not in the aspect of CSV. So remember that you use open PyExcel. This will read the Excel in for you. So if you need to install it, you just need to do pip.install, like pip install open PyXL. So with that, this will now helps you make it done. So in this way, so you should be able to read the Excel for you, and that is the reason why it didn't fail for me. Is that okay? So remember that
Yes.
anytime you put it up here, so for me, I can now call the dx dot, then because I have done the dx, so I can now say here, okay, let me start with the head. So I can now call for the head, and then you can see the different that I have here. Then I can say ds dot, plot like this, and then I run it, I should be able to have something like this. And then if I want to plot anything, so I can still say ps dot, then I will now call that I want it to plot, but now in this format I want it to be a scatter, for example. And then when it comes to scatter, what do I want to be in the x-axis, for example? Remember, I've read the head here, so I need the x to be in the x-axis, so I'm going to put this and say x in the x-axis. And then I'm also going to y, I'm going to say y have also to be in the y-axis like this, and then I can close that. And if I run that, I should be able to have something that looks like this. So what did I do? This is the eastern and northern coordinate of Enugu, I think somewhere around Enugu. So you can see now that I have imported this in this. So the same way I import this, I can, when we'll be using GeoPanda, we can see how we can create a dynamic maps, which we can use, maybe bring in open street map layers, and you can interact the building footprint or road network. So this you can host it on online or wherever, whichever way you want. So you can do some things like this because you have access to them. This is something somebody is actually working on, and he's doing very, very great on it. So we also supposed to be looking at how we can work with this kind of data, where we can get the data, create it, and then should be able to load this kind of data that is loading, though it's taking a bit time. But you can make this kind of data and make it dynamic, so where you can query, you can upload any data you want at any point in time. But what I just need you to know is that you need to have the basics of the data we are going to be working on, and how do you use them anyway. So I think it's taking a bit time, but you see the way I'm bringing this, so I can now choose to know what happens. So if I want to check, plot the elevation of the data I have, so remember I put it in dx, so I can bring in here and call it as z. I want to see the elevation changes of the data I'm working on, and then I can now close it up and I can say the plot. So if you now go in here, and then you should be able to see this is the elevation changes of the data I have, because it have, as you see here, you have x, y, and z, and then this is the changes in elevation based on what you see here. So you can see the variation as it changes. So this is the number of points. So because if you go to the Excel here, you can see that the Excel file we have here, which we read, this is Excel here, which is opening for me. This is Excel reader here, as you can see. This is an Excel reader, so it is opening for me what I want it to open. You can see down here, you can see the number of points I have here. So if I go down a bit, you see that I have almost 5,661, that is 5661. So if you return back here, you see 5,661. So this is the elevation changes over this place. So you can see here where we have in here, from here it's 127, the highest point here is 145. So you can see the elevation changes over time. So you can see, I just say plot this for me, and then you should be able to see. So if you have something in mind, I want it to plot in x and y, so you can also put it in z axis and run it like this, and you should be able to have this. So what do I need? I want to see the horizontal changes of those properties over time. So what do I need to do in x translation? So I put x and y, so you can see the changes here. So this is the changes that happen where you have from the this particular longitude or latitude. So you can see the changes we have here over time. So the same way you can also change it here. I want y to come in here, and I will run the same thing here. So you see the changes in as related to y being here, and then z going up here, because this is the changes in elevation. What am I trying to say? I just want you to understand that most of those data, because we are looking at creating a different thing that's related to geospatial technology, so we will be using most of these data. You can use this to augment it with the raster data, use it to augment it with the vector data, point line, and polygon. So you can overlay, you can do those things within ArcGIS. So we can bring them here by writing this type of thing, so you can read Excel data and then be able to plot it whichever way you want. So